So up to this point, you've learned mostly about galvanic cells. So in this lecture, we're going to be focusing a bit more on electrolytic cells, which are non-spontaneous, or we say thermodynamically unfavorable reaction. Okay. So if you look at this picture right here, you can see that the chlorine is being oxidized while the sodium is being reduced. And the reduction potential for chlorine to go from Cl2 to Cl negative is positive 1.36. So since this is occurring as an oxidation, this forms oxidation potential right here equals negative 1.36. And then sodium, on the other hand, has a reduction potential of negative 2.71. So if you were to find the total E cell and you add these two numbers together, both negative 1.36 and negative 2.71, you're going to notice that it's going to be less than 0, okay, which means that as a result, delta G for the cell is going to be positive, and thus it would be non-spontaneous. Okay, so anyway, this is the process of electrolysis, which is when you need to force a voltage source, an external source of electricity right here, in order to drive the reaction to make this happen. Okay, so in this reaction, table salt is in here, and the chlorine ions produce chlorine gas, and the sodium ions produce sodium, and actually it should be aqueous sodium ion. Okay, but we'll talk, what we'll be doing in lab about this shortly. Okay, so if you look at this, let's see, list of equations here, the question is asking you what happens if you carry out electrolysis on an aqueous solution of CuBr2. So let's go ahead and write the equation for the electrolysis of CuBr2, which is the separation into different ions. Okay, so what's happening here is that CuBr2, okay, aqueous, is transformed into Cu solid and Br2 liquid. And we're going to go ahead and break up the left side to do the net ionic equation to say Cu2 plus aqueous plus 2 Br minus aqueous gives you Cu solid and Br2 liquid. And let's go ahead and separate these into the two half reactions. The first one being Cu2 plus 2 electron gives you Cu solid. And then the other one would be the oxidation equation, 2Br negative aqueous yields Br2 liquid plus 2 electron. So since the first one is being reduced, we're going to go ahead and list this as a reduction potential and the second one as an oxidation potential. If you look right up here, the reduction potential for this process is positive 0.34. Okay. So let's do right here, 34 voltage. And then the reduction potential for the second one, the 2BrAQ, would be the opposite of the positive 1.07 voltage. So we'll make that negative 1.07 voltage. Okay, so E cell, again, okay, when you add these two numbers together, it'll be positive 0.34 and negative 1.07, and that would give you negative 0.73 voltage. And as you can see, that's because it's a negative sign, it is non-spontaneous, and you need an external source of electricity in order to force the reaction to occur. And what you will see is that you will see a solution of copper 2 bromide. And as you drive an electrical current through it, you're going to see copper solid forming on one of the electrodes and bromine liquid forming on the other one. Okay, and so the whole point of this lecture is to determine how many grams of copper the solid would form in the process of electrolysis in like this specific example. Okay, so let's go ahead and move on to the next page, and we can see how the calculations come into play. Okay, so we know how much you love stoichiometry, and this is another way that we can incorporate stoichiometry into chemistry. And so in electrochemistry, what we have here, electrolysis, is in stoichiometry, you would determine how much material you can obtain from electrolysis. So like in the example we just did a few moments ago, it would be talking about how much copper metal could be obtained through the process of electrolysis. Okay, so you should first be very familiar with this first part right here, which is the grams of substance and converting it to moles. Okay, then you also have to use the half reaction to determine how many moles of electrons are being transferred. Okay, now this is kind of going to a bit of physics right here at this point, but one thing you should know is that we use what you call the Faraday constant. And on the AP handout, it is 96,485 coulomb. Okay, use that as a capital C per mole of electron. Okay, so I'm going to say over 1 mole of electron. Okay, and what coulombs is that it's a charge. It tells you the charge, the overall charge per every 6.02 times 10 to the 23rd electrons that you have, like the total amount of charge that they carry. Okay, and then the other thing that you do need to know is that the current, the total number moles of electrons, the current is, it has the formula on the AP handout. It is I equals Q. Okay, Q in this case is the charge over T. Okay, and I'm going to put a note right here that I equals the current, okay, which is the flow of electrons. It's a measure of the flow of electrons. You'll learn more about that in physics, which is the unit A for amperes. Okay, Q is the charge in coulomb, and T is the time in second. Okay, so make sure you note those. Those are the units, and those are the very specific units for this. Okay, so let's go ahead and apply these calculations. So as we look at this problem, the house question is asking you for how many grams of copper are deposited on the cathode of an electrolytic cell if an electrical current of 2 amperes, okay, is run through a solution of CuSO4 for a period of 20 minutes. Okay, so we know that the current is I, and that equals 20 amperes. Okay, we also know the time is 20 minutes. Okay, and we need to make sure that you convert that to second. Okay, so we're going to multiply that by 60 to give you 1200 seconds. Okay. And ultimately, our goal is to find out how many grams. Okay. So the first thing that you should do is that you should do the half reaction. So we know that copper, aqueous copper ion, Cu2 plus, are going to be transferred into Cu solid. So Cu2 plus aqueous and Cu solid. And then to balance that, you have to make sure we add 2 electrons. So that the charge goes from 2 plus to 0. So that means 2 electrons will be transferred. So 2 moles of electrons for every mole of Cu2 plus. Okay, so the first thing you're going to do is we're going to figure out the Q, the charge. So if we recall on the last slide, I equals Q over T. So 20 amperes equals Q over 1200. And then we're going to go ahead and multiply both sides by 20, and we're going to get Q for 1200. Q equals 24,000. The units will be C for coulomb. Now, if you recall in my last slide, I said that if you have 1 mole of electron, that's going to give you 96,485 coulomb. Therefore, using in the sense of proportional reasoning, if you have 24,000 coulomb, okay, you can divide that by 96,485, okay, to give you a total of 2.49 mole of electron. And then, the next reaction we can go over here, if you look at the half reaction, it is that for every 2 moles of electrons, you have 1 mole of Cu. So if you have 0.249 mole of electron, we're going to go ahead and divide that number by 2, and that would give you 0.12, maybe about 0.125 moles of Cu. And then the final step is to multiply that 1.25 moles of Cu by the molar mass of Cu, 63.55 grams per mole. And that will give you a final answer of roughly 7.92 grams of Cu. Okay, so what I'd like you to do is go ahead and take a look at the next problem on the next slide and see if you can try to apply what you just learned in this problem. Slightly different, of course. Okay, so when you look at this problem, go ahead and give it your best shot for a moment. Pause the video and see how far you can make it. And then if you get stumped, you may go ahead and resume playing this video. All right, so what you have to do first here is that you should do an equation for the half reaction from nickel 2 plus aqueous to nickel solid. So once again, like in the previous problem, you have 2 moles of electron for every mole of nickel. Okay. Now we're now going to take the grams of nickel, so we're going to say N equals 0.500 grams of nickel, and divide it by the molar mass of nickel, 58.69 grams per mole. And that's going to give you 0.00852 mole of nickel. Okay, and then according to the half equation that we did up here, for every 1 mole of Ni, we have 2 moles of electron. So based on that 1-to-2 ratio, if we double that, that is 0.0170 mole of electron. Okay. Now, once again, based on the Faraday constant, for every mole of electron, you have 96,485 coulomb. Okay, so 0.017 mole of electron. Okay, where if you multiply that number, that'll give us about 1643.98 coulomb. 98 coulomb. Okay, then we have the equation I equals Q over T, and we're trying to find out how much time it would take. So I would be 1643.98 coulomb over time. And then when we divide that, okay, and multiply and divide everything here too, you get T equals roughly 548 seconds. Okay, so that pretty much concludes all the lectures that you're doing for the unit and pretty much for the year. So go ahead now and take what you've learned, and you can be working on the practice problems in the book as well as the pre-tests. And thank you.